Okay, so in this video, I'm going to introduce you to the absolute basics of object-oriented programming. So we're going to see that in a real life, we use objects to accomplish a task. Now that's overly simplified. You don't know what I'm talking about because you do this every day, every second of the day, without without thinking about it. And what we also do is, in real life, we group the objects according to what they do. And again, that's something that we don't think about. We just do it. Another thing we don't think about is we can't use that functionality of that object or device unless that object exists. Again, too easy, too automatic for us to really understand that. All objects must have unique names. Okay? Terminology we're going to deal with is instantiation, or to instantiate something, objects and classes, functions, behaviors, and methods. Alright. So first of all, let me show you what we're going to be creating, what object-oriented programming looks like. So the result that we're going to so here's our program. Okay, so when we're done, we're going to have a program that outputs hello world. Okay, you can see that I'm going through my server and it just outputs hello world. Now we've done this before, except now we're going to use object-oriented programming to do it. Now what that program looks like, it looks more complicated than it should be, but again, we're just learning how to do this. So here's my main program. Alright, so in my main program, it includes two classes. Alright, so here's the first class. Here is class hello world, and you can see here, this is where it actually outputs the hello world. You notice that the hello world is not outputted by the main program. It's a class that does it. Okay, more specifically, down here is we're using that class. We're using that class HW, to create a new object, and that object is called out. We're going to use that object to run a function that is defined in the hello world class, and then this function is going to output hello world for us. Okay, and similarly, we have a second class. Okay, and in that class is called class HTML. You see down here. Alright, and in class HTML, what we're going to do is we're going to print the page headers, okay, and the body, and then the end of the page stuff. Alright, so in here we see that we included this class. So we included this class here, and once it's included, that means we can use it. And then in here you can see that I used this class to create a new object called page, and then once that object exists, then I can use that object. I can use the functionality associated with that object in order to do something for me, in which case is to print these HTML headers. Okay, now you're not really sure what I'm talking about right now, so let's take it nice and easy. Let's go back and talk about object-oriented programming. So you see here, this is my main. See here, this is my main program. Okay, and I've attached two classes to it, class HTML and class out. Alright, and all the things I want to do, all the things I want the main program to do, instead of using the main program to do it, I delegate it to the classes to do it or to the object to do it for me. Okay, so I'm using various objects in order to do something with me. You notice back here in the program that this program doesn't really do anything. Okay, it doesn't print anything on screen. It uses the objects, okay, which I created here. This is how I made the objects exist in order to do the work for me. I divide the functionality between two different classes. Okay, so that was a crash course introduction to object-oriented programming. Let's see how object-oriented programming works in real life. In real life, we have a task. Okay, we have a problem that needs a solution. The problem is we want to eat our pancake breakfast. Now, in real life, what we do is, and we don't think about this, we just do it. How do we eat a pancake breakfast? Well, what we do is we need to assemble the objects in order for us to accomplish this task. The objects that we assemble have the functionality we need in order to do what we want to do. Okay, so the objects that we need are, we need a plate, okay, because the plate is going to hold the pancakes. We need a fork, because the fork is going to poke or scoop the pancakes, and we need a knife, something to and the knife is going to offer the functionality of spreading the butter and spreading the syrup. Okay, so we assemble these specific objects, okay, because these are the three objects we need to accomplish our task, or more specifically, these objects provide us the functionality that we need to accomplish this task. All right. Now, if you want to get a little fancier, you know, in order to make the pancakes, we need a lot of other objects: oven, spatula, butter, eggs, flour, pan, and a mixer. Okay, all these objects, you notice that provide a certain functionality. They do something for us in order for us to accomplish this whole task. Now, that functionality, okay, I'm going to call methods or behaviors. So they do something for us. They're functional in some way. They have a method or behavior that we need in order to accomplish our task. Okay, and you notice that no one single object in you notice that no one single object can give us all these functionalities at once. Okay, there's no one thing that can do everything for us. They're automatically divided into different objects. Okay, and we use the functionality, the behaviors, the methods in order to accomplish a task for us. Okay, let's move on. So the fork provides us functionality such as poke, scoop, and move. Okay, a fork might be able to move something around. All right, this is the functionality a fork provides, different from a plate and different from a knife. A knife provides us the functionality of cutting the pancakes and spreading it. So these are called this is the functionality associated with this object. We can't use the functionality unless this object first exists. I'm going to call this functionality behaviors and methods. Alright, so here's another problem or task, is I need to write a science report. I'm doing a science experiment for class. Now, what are some of the objects that we need to assemble in order to accomplish this task? Well, we might need a pencil. We might need a camera to take some pictures or a video. We might need a computer to type out a report. Might need a scanner to scan some information. Might need a printer to finally print out a report. As you can see, each one of these objects, okay, offers a unique set of functionality or methods or behaviors that we need to accomplish this task. All right. If this object doesn't exist, if we don't have a pencil, it's very silly for me to say this, but if you don't have a pencil, then you can't use it. You can't use the functionality. You can't use the methods. You can't use the behaviors. And same with the rest of them. Okay. So a pencil might provide us two functionalities or behaviors or methods: write and erase. You notice that the pencil provides these two functionalities because they are related to a pencil. Okay. For example, you would not have a printer would not provide you an erase function because that's not related to what a printer does. Okay. A camera will have a lot of functions: take a picture, film video, show pics, delete pics. These are the functions, behaviors, or methods related to the camera object, which we can't use unless it exists. So, with regards to related functionality, one of the things we need to understand is that the pencil related functionality is grouped with related objects. So a pencil will offer the functionality of writing, okay, and erasing. They're related, therefore they're bundled together. Okay, you know, a watch has related functionality. You see watches that have a clock, that have a stopwatch function, that have an alarm, might even have a calculator in it. Okay, this is all related functionality to a watch, to the watch object. Okay, they're related methods, behaviors, and functionality. Okay, so a phone can do many things. You it could be a phone, calculator, email, call display device, web, music, video, video and camera, etc. Okay, all those related functionality of what a cell phone might do these days. Okay, now what you won't see is you won't see a cell phone with a built-in pencil eraser. You won't see a cell phone with a built-in pencil eraser, because a cell phone is not expected to have that functionality. I mean, showing this picture is kind of ridiculous. Can you imagine buying a cell phone that has an eraser as well, just in case you want to use a cell phone to erase some pencil, something written in pencil? It's ridiculous, silly. So why in programming would you have unrelated functionality in certain classes? Okay. So that kind of introduces us to what we want to do with the main program. With a similar idea, as I said, let's go back and look at our program here. So here's our program. So here's the main program. So this is the task. Okay. So if you go back to here. All right. So the main program is basically the task. This is what we want to accomplish. In this case here, we just want to accomplish, we just want to print output world screen. All right. So this is the task, okay, and we assemble the objects that we need to do it. All right, to accomplish that task. In this case here are the objects that we need to assemble to do our task. All right. So in this screen, what we're doing here is we're making those objects exist. We're creating those objects. Once we create the objects, we call it an object called page, an object called out. Then we could use that object, okay? We could use that object and the functionality or the methods and behaviors related to that object. We can't use this object unless we first create it. Just like I can't use this pencil object, okay? I can't use this pencil object unless I first make it exist. Unless it exists. Alright, it's the same kind of thing here. I need to make the object exist, okay, before I use it. So and here you see that I'm using the object, I'm using the method or functionality or behavior associated with this object which I created up here. Okay, so where this differs from real life is that in programming we get a chance to, I mean, in using these objects, everything you do, you brush your teeth, you comb your hair, you put on your shoes. Have you ever thought for a second that how do those objects exist? Now we use the functionality of a toothbrush, we use the functionality of a comb, okay? We use the functionality of a hair dryer, but how do they exist? Okay, how are they? How do they exist? Like, what makes them exist? Well, it's obviously some kind of a blueprint, some kind of a plan that manufactures these items, and then we go and we make them exist by buying them from a store. Okay, so that plan, how to manufacture a pencil, to manufacture a camera, might be a blueprint of some sort. So the classes are basically the blueprint. They are the instructions on what the functionality, what each of these functions does. Okay, so in this case here, class hello world defines what the object does. In this case, the object does one very simple thing. It just outputs hello world. All right, this object can be quite complicated. It can define a lot of things. Okay, and this class here, class HTML, it's slightly more complicated and does two things. It prints out a page header and an end page. All right. Now, so just like in real life, the plans to create a camera might be a set of blueprints, might be such a set of electrical schematics. Now, you can't use a set of electrical schematics or blueprints and take a picture with it, right? You can't do that. Just the same thing in here. I can't use a class and actually do anything with the class. In order to make a camera work, I need to use the object, the camera object, not the blueprints. Okay, blueprints are just a bunch of paper that says how to make one and what the camera does. It doesn't do anything. It's only the object that provides us the functionality. Okay, and just like here, this is a set of blueprints. It just tells us how the object works, but it doesn't work itself. In order for me to use the functionality or the behaviors and functions and the methods associated with this class, I need to make it into an object. And here is me making into an object. Alright, more specifically, here is me making this class into an object called out, and here is me using out, okay, to to run a behavior, a method, a functionality which is defined in the class. Okay, and just like in real life, we would not bundle unrelated functionality with unrelated objects. Okay, we divide our programming, okay, into classes that are related to each other. So this class here is all the coding related to whatever this class does. This class here deals with all the coding related to this class, and then if we have more coding, more functionality, or more behaviors that are not related to these ones here, what do? We start a new class, right? So we divide classes into related functionality, so we can have as many classes as we want. Now, object-oriented programming is complicated, is difficult. There are many uses and purposes for it, and this really outlines the core, a few of the core principles behind object-oriented programming. But there's a lot of really interesting stuff that object-oriented programming does, which we'll get to shortly. Okay.